So now we're talking about the small intestine. We're in the middle of talking about the organs that digest food. And so we started with the mouth. The GI tract goes from the mouth to the pharynx, which is your throat, to the esophagus, to the stomach. And then here's the outline of the stomach. And then here's the small intestine. And the food weaves through that to the large intestine. And so the large intestine is not longer, it's actually just wider. And the small intestine is actually very, very long, but it's got a small diameter, so that's why it's called the small intestine. Digestion continues, and the important thing here is that it's completed in the small intestine. So if you're not sure what the answer to is on a quiz, chances are it's the small intestine because everything happens in the small intestine. So for example, carbs. Carb digestion starts in the mouth, but it's completed in the small intestine. Protein digestion starts in the stomach, but it's completed in the small intestine. Lipids. Lipid digestion starts in the small intestine and is finished in the small intestine. Nucleic acid, same thing. Started in the small intestine, finished in the small intestine. So seriously, if you're not sure what the answer is, it probably is small intestine. Many of the required enzymes are supplied by this organ right here. It's called the pancreas. And so your stomach would be, so if you look at this, here's the stomach. It's kind of hard to see on this. And here's this little section is the liver and the gallbladder. So here's the liver, here's the gallbladder. This is the small intestine, and the food had just come out of the stomach, which would be up here. So as the food comes in here, there's a little sphincter muscle, and it's closed, and the pancreas makes digestive enzymes. When food comes through here, this sphincter will open, and the enzymes from the pancreas can go right into the small intestine and work there. In a little bit, we'll see what the liver does, but the liver has something called bile, which it will make and also secrete into the small intestine. Here's just a bigger overall picture. This I like because it focuses right in on the pancreas, so you can see what it looks like. But this picture is nice because it shows you the stomach, the small intestine, and the large intestine. And it shows you the pancreas attached right there, secreting stuff right into the beginning of the small intestine. Virtually all nutrient absorption, I think that was supposed to slide in, sorry. Absorption takes place in the small intestine, so I think you have to write this in. So what does absorption mean? That means you're taking nutrients from the small intestine out to the blood. So like a sponge will absorb water, the same thing. Your blood will absorb the nutrients. So you'll have fatty acids, you'll have amino acids, all the smallest parts. You'll have monosaccharides like glucose. All of the big molecules are done being absorbed, are done being digested here, and then they move out to the blood. If you don't digest them in the small intestine and the food gets all the way to the large intestine, it's just poop at that point. Here's a great movie that you won't be able to see, so I'll do that one for you in class. Okay, what are these for? So here's your small intestine. It's got muscle, so longitudinal muscle, I think I talked about earlier. Circular muscle goes around the whole thing. In here, do you see all the bumps? So we've got those bumps. And then, do you see these things? These are called villi, or one would be a villus. And in each villus, you've got blood vessels, and this is a lymphatic vessel, which is sort of like a blood vessel. So all of these finger-like projections have this. And if you look on the surface, see how it almost looks hairy? If you look on the surface of the cells, here's a cell, and there are little things that go up and down here too. Those are called microvilli. So I'm wondering, what are villi for? Why do you have all these bumps? And even with every single one of these thingies coming up, each cell has this kind of bumpy cell surface. So the question is why? What are they for? So pause this for a minute, please, and think about that, and you'll get the answer when you come back. No, really, pause it. So villi, that's these, and microvilli, which are these, increase the surface area of the small intestine wall for more digestion and absorption. Probably going to be absorption. If you've ever known someone with celiac disease, their small intestine, instead of having all the bumps like this, so your small intestine, if you don't have celiac disease, looks like this. And so tons and tons of surface area. So the food can go in here, or 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 in through here, or through here, or here, or here. There are so many places for the food to enter. If this thing weren't here and if it were flat, there would only be a little bit of space for the food to make it in. So instead of having something like this, in celiac disease, it's I think it's an autoimmune disease, but you're attacking, well, it's because you have gluten in your diet, and that's in wheat, barley, rye, and oats. And I'll have to look it up, but it's something about your body attacking its own villi when you have those. And so if you take gluten, which is those grains, completely out of your diet, you should go back to the villi type appearance. And so the thing with these people is they get, so think about the problem that someone would have if they lose all that surface area. So the food doesn't have as many places to enter the bloodstream. And what happens in that case? So the food would be in here and it can go into the bloodstream. The food would be here, it could go into the bloodstream. The thing is here, there's not that many places for it to enter the bloodstream compared to this absolutely enormous surface area. And so people with celiac disease are often malnourished. They have diarrhea and they're just not getting the nutrients that they need. Quiz time. Which organ begins protein digestion? So pause and I'll give you the answer. And the answer is the stomach. Which organ begins carbohydrate digestion? If you actually did that lab I mentioned and ate the cracker, you would know. But you probably didn't. No one ever does. So anyway, that would be the mouth. Where is salivary amylase made? That's tricky. It's used in the mouth, but it isn't made there. It's made in the salivary glands. Ooh, I wish I hadn't said that earlier. Where does salivary amylase work? And that would be the mouth. And that's what your spit is. Saliva is another name for spit. What's the function of villi? To produce digestive enzymes, to increase the surface area of the small intestine, to move food along the small intestine, or to prevent food from moving backwards along the GI tract. So let's start from the bottom. To prevent food from moving backwards. Nope, the thing that prevents food from moving backward are those circular muscles called the, let's see if I can spell it, sphincters, something like that. To move food along the small intestine, this is the number one wrong answer that people pick. Because they look like things that could move stuff along. They look like cilia, if you saw that in middle school. And they do. They look just like cilia. Cilia has maybe it'd be a cell like this with a bunch of little thingies sticking up that kind of beat stuff along and help things move. That's not what this is, though. These are not for that reason. They increase the surface area of the small intestine. So that's the right answer. And here's the thing though, produce digestive enzymes. Actually, the lining of the intestines does produce digestive enzymes, so A is actually also correct. Which organ begins lipid digestion? So remember I said the answer to almost everything is small intestine. Here we go. Small intestine. Yes, it is. Which organ does nucleic acid digestion begin? Yep, small intestine. In which organ is the digestion of all nutrients completed? Are you ready? Small intestine. In which organ are almost all nutrients absorbed? Oh, what is it? The small intestine. All right, liver and gallbladder. So we're done with the GI tract, which is all, oh no, we're not. I haven't done intestines yet. We're skipping over to the things that help. So this is one of the helpers, the liver. The liver does a million things. One of those things, so it detoxifies poisons from the blood, but it also does some digestive stuff. So the thing that it does is it produces bile and secretes it into the small intestine. So the bile is made here and it goes down here and it gets into the small intestine. And you can see a better picture of it here. Here's the liver and it's got a bunch of ducts and the duct will secrete bile into this tube which will then secrete it out to the small intestine. Bile actually does this thing called emulsification. So bile emulsifies fat, which means, so you should pause this so you can write that enormous word down, which means it breaks them up into tiny particles so that they're more accessible to enzymes. So bile actually is not an enzyme. Here's a fat droplet, and the enzymes can get at all the outer parts. But if you took that and cut it in half, now the enzymes could get to all those same places it could get to before, but the enzymes can get in there too. And if you cut it in half again and again and again, you have much more places for the digestive enzymes to work. So that's all bile does. So bile is not an enzyme because it doesn't actually break anything down chemically, it just physically breaks stuff apart. And then here's an interesting thing. If you make bile and you secrete it down to here, but this sphincter is closed, you're going to start to have backup. You filled this thing up and the bile keeps dripping down, and you filled it up and the bile keeps coming down, and you've filled it up. Eventually the bile is going to back up into this thing called the gallbladder. And that's the only function of the gallbladder, at least that we know of. It stores extra bile. So extra bile backs up into the gallbladder where it's stored. When this opens, there's a hormone actually that will make, it'll cause the gallbladder to contract and squirt bile in here, especially if you have fatty foods. You can live without your gallbladder. Lots of people have it taken out. It's not really, well, my sister had it taken out about 10 years ago. Not really a super big deal for her. You're supposed to not eat fatty foods as much, and you're supposed to eat a lot of smaller meals. And I'd imagine for some people it affects them a lot. My sister eats whatever she wants, and she's fine. Pancreas, that's this thing. It secretes digestive enzymes. In fact, it secretes a ton of digestive enzymes into the small intestine. So secretes enzymes into the small intestine. So the food doesn't actually make it into here, but the enzymes that are in here make it here and digest the food that you eat. That looks good. Enzymes break down all categories of food. So carbohydrates, lipids, protein. Excuse me, proteins and nucleic acids. Pancreatic enzymes. These are the enzymes that the pancreas makes. And luckily they're all nice and easy. Proteases digest proteins. This is the only bad one. Pancreatic amylase actually digests exactly the same thing as salivary amylase, but it doesn't start with the right letter. Boo. It's too bad it didn't start with a C. Anyway, it breaks down carbohydrates or polysaccharides. Lipases break down lipids. And guess what nucleases break down? You've got it. Nucleic acids. So, one more really funky thing. Remember the pH scale? Remember, it goes from 0 to 14 with 7 in the middle. And if you sing your alphabet, A, B, you'll do fine. Stomach is pretty acidic. If you throw up, you've noticed that it burns your mouth. It's disgusting, and you have to go brush your teeth or you don't feel right. And if you have indigestion, if you get heartburn a lot, then you know your esophagus hurts because the acid is starting to burn a hole in your stomach along with the enzymes. So by the time you poop it out, unless you have diarrhea, it's been neutralized. And remember, pH right in the middle, pH 7 is neutralized. So something had to neutralize the acid. Remember, acids release hydrogen. Bases release OH. If you bring an OH together with an H, you get HOH or H2O. You get water, the most neutral thing ever. So this actually, this is the food coming from the stomach is acidic. The pancreas releases basic stuff to neutralize that so that by the time it goes all the way through your system, it's totally neutralized and your poop is not acidic anymore. So basic secretions of the pancreas neutralize the acid coming from the stomach. Thank you, pancreas. All right, I think I'm going to be done. Bye.